Assalamu alaikum. In the 7th lecture, we will learn about harmonic progression or harmonic sequence. Its short form is HP and it is defined as a sequence whose reciprocal terms are in arithmetic sequence. Now here in this topic, we will follow terminology of arithmetic sequence in reciprocal form. So let us consider two examples of harmonic progression. Now you may notice that the denominators which are present here in each term are in arithmetic sequence. Here the denominator of first term is 2. When 2 is added to this 2, it will become 4, and then again when 2 is added to this 4, it will become 6, and again the addition of 2 with 6 gives 8. So it's now clear that the denominators are in arithmetic sequence. So their reciprocals, that is 1 upon 2, 1 upon 4, 1 upon 6, 1 upon 8 and so on so forth, are in harmonic progression as per definition of harmonic sequence. So let's have a second example. Here again you may notice the denominators. Here the powers of 3 are going on, and you may notice here that the powers are actually in arithmetic sequence. That is, plus 1 is added in each denominator in its power. So the denominator is in arithmetic progression. So their reciprocals are in, which are 1 upon 3 power 1, 1 upon 3 square, 1 upon 3 cube, 1 upon 3 power 4 and so on so forth. So their reciprocals are in harmonic progression. Now we have general term of harmonic progression. As I have already cleared you that here we will use the terminology of arithmetic sequence in reciprocal form. So these terms are actually, their denominators are the general form of arithmetic progression, which are a plus d, a plus 2d and so on so forth. So this is the general nth term of arithmetic progression. So their reciprocals 1 upon a, 1 upon d, 1 upon a plus d, 1 upon a plus 2d and so on so forth, and in last the nth term 1 upon a plus n minus 1 times d are in harmonic progression. So let us suppose a and b be the first two terms of harmonic progression. So a, b are in HP, then the definition implies that their reciprocals should be in arithmetic progression, and we know the formula to find the common difference of arithmetic progression, which is any term not first term. So here we have only two terms, 1 upon a and 1 upon b, which are in arithmetic progression. So the only option which we have is the second term, which is 1 upon b. So common difference formula is any term minus its preceding term. So let us simplify it. The LCM will be BA, that is b into a, which can be written as a into b. So this a will multiply here with this 1. So 1 into a is a, and this b will multiply here with this 1. 1 into b is b, and the sign will come in between these two terms. So this is the common difference for the two terms which 1 upon a, 1 upon b, which are in arithmetic progression. So now let us find nth term of arithmetic progression with respect to these reciprocal terms. So the formula which we know from our previous lecture is that the nth term of arithmetic progression is a plus n minus 1 times d. But here in this situation, the first term of arithmetic progression is 1 upon a. So here instead of a, we will substitute 1 upon a, which is written here, and after this plus sign is present, then n minus 1 is written, and the common difference of this situation is a minus b upon AB, which is substituted here in place of common difference. So let us simplify this. The LCM will be the first term denominator is A, the second term denominator is A into B. So their LCM is A into B. So here A is present in the denominator. So definitely this B will multiply here with this one. 1 B is a B, and there is no change, there will be no change in the denominator because the whole LCM is present here in its denominator. So the numerator is written as it is. So this is the nth term of arithmetic progression with respect to this situation, and the definition of harmonic progression implies that the reciprocal of this nth term will be in harmonic progression, which is written here, that is A into B upon B plus n minus 1 times A minus B. So this is the nth term of harmonic progression which we have derived here. So let us have two questions related with this topic. The first question is written here. Find the 17th term of an harmonic progression. 17th term is required whose first two terms are 6 and 8. So we know that from the derivation of harmonic progression, A is supposed to be the first term. So here we suppose A equal to 6 and B equal to 8, the second term. So nth term of harmonic progression which we have derived just now is written here. Let us substitute the values of small n, A and B in this formula. So when n is equal to 17 here, so let us substitute n is equal to 17 in their respective positions, and in place of A we will substitute 6, that is 6 in these positions, and in place of B which is present in 3 positions we will substitute 8 here, here and here. So it is written here. So let us simplify further. 6 8s are 48, 17 minus 1 is 16, 6 minus 8 is minus 2. Then in the next step, plus into minus is minus, 16 2s are 32, and their difference, that is 8 minus 32 is minus 24, which is written here in the next step, and 24 1s are 24, 24 2s are 48. So using the table of 24, the required nth term of the harmonic progression is equal to minus 2. This was the required answer. So the next question, second question of this topic is the 12th term of an harmonic progression is 1 upon 5. So in the solution we have written 12th term of HP is equal to 1 upon 5, and from the definition we know that it's a reciprocal which is 5 upon 1, which is actually 5, will be in arithmetic progression. So the 12th term of arithmetic progression is 5 here. Then in the statement of question, 19th term of harmonic progression is given 3 upon 22. So definitely as per definition its reciprocal will be in arithmetic progression, which is 22 upon 3. So 19th term of arithmetic progression here is 22 upon 3. And in last, find the 4th term. So we have to find the 4th term of harmonic progression here. So as we have converted the 12th and 19th terms in arithmetic progression form, so we will use the nth term formula of arithmetic progression here. So for the 12th term, here we will substitute in this formula instead of n 12. So T12 is equal to A plus 12 minus 1 times B, and the 12th term is equal to 5, so it is equated to 5 here. And similarly for the 19th term of arithmetic progression, instead of n we will substitute 19 here in these positions. So here 19 and 19 is substituted. So following this formula, A plus 19 minus 1 times D, which is the 19th term formula of arithmetic progression, which is equal to 22 upon 3. So let us simplify here. 12 minus 1 is 11, so a plus 11d is equal to 5, and here a plus 19 minus 1 is 18, a plus 18d is equal to 22 upon 3. So here we have two equations. So let us solve these two equations simultaneously. So let us subtract equation 1 from equation 2. So the equation which is going to be subtracted is written below, which is written here, and from which this is going to be subtracted should be written above. So equation 2 is written here above. So as we are subtracting the equation which is written below, the signs of all the terms of the equation are changed. Here we have plus a, so instead of plus it will run with minus. Here again 11d sign is positive, so now 11d will run for negative sign, and the sign of 5 is plus, so its sign will now become minus. So now we simplified. Plus a minus a will cancel. Here plus 18 minus 11 is equal to 70. Now plus 22 upon 3 is written here. Then after this we have minus 5 here. So now we will simplify further it in next step. The LCM of right hand side is 3, which is written here, and 3 will multiply with this 5, so 3 5s are 15, and 22 minus 15 is equal to 7, and we have to find common difference. So this 7 will cross multiply here in the next step, which is written here, and using the table of 7, which will go 1 times to the numerator and denominator. So the remaining of this fraction is 1 upon 1 3 is a 3. 1 upon 3 is the common difference which is found here. So as we have computed this the value of d using equations 1 and 2, so we can substitute this value in any of these equations. So let us substitute this value in equation 1 here. So here it is written here. So a plus 11 times 1 upon 3 is equal to 5. So their multiplication is 11 upon 3, which we shift in the next step to right hand side. This will become negative. Here the LCM is 3, so which is written in the next step. So 3 5s are 15. So the numerator is 15 minus 11. There is no change here because the LCM is 3. So 15 minus 11 is 4. So the value of 1, which is the first term which we have obtained here, is 4 upon 3. But these two values are for arithmetic progression. The setup is going for arithmetic progression. So the fourth term, but we actually are interested in the fourth term of harmonic progression. But first we will find the fourth term of arithmetic progression, because all these adjustments which we have completed up till here are for arithmetic progression. So here we will substitute n is equal to 4 in these two positions. So the fourth term of arithmetic progression is equal to, here we have to substitute 4. So a plus 4 minus 1 times d. Then we will substitute the values of a and d from here and here in their respective positions. So a is equal to 4 upon 3, d is equal to 1 upon 3. These are substituted, and you may notice that in the first term and in the second term 3 is present in the denominator. So let us take this 3 as LCM, and the numerators are 4 plus 3 ones are 3. So their addition is 7. So the fourth term of arithmetic progression is 7 upon 3, and we know that we are interested to find the fourth term of harmonic progression. So its reciprocal will be the fourth term of harmonic progression. So this is the required answer of this second question. Thank you.